This video will give an overview of the FullRank HypoInspector. This HypoInspector tooling is used to review previously created hypotheses or ensembles from either the prospecting tool or the AutoML tooling. So let's refresh that list. Again, this is loading out all the previously existing hypos from disk. So we can see here that if we select these, it'll give us a nice graph in terms of that displays the error. So you see here that the error metric is around 18, which and so we can see the different instantiations have different errors depending on how accurate they are. And we can see here there's some qualities of each of the hypo ensembles or hypothesis ensembles. So this one's a gradient boosting one. It has size of 11. There's a creation date and time. This is the target variable. These are the input variables. So you can see there's quite a few. And note that the size is not necessarily equal to the input variable size. So it might be more or less depending on how it was generated. And so you can kind of browse through these and kind of determine which ones are suitable for a particular task. But let's pick one that's relatively straightforward, just to make things a little more clear. So here's an interesting one. It has the size of 5 and it has some complexity to it, but nothing that's too complex for instructional purposes. So let's inspect this one. We can see here the key things or key, I guess, panels for the inspector are these last 3 panels. The first 2 were explained in the hypo prospecting video. So if we look here, if we click on the test panel, we see that it just gets a random observation from the data set. We can get basically a random value. And on the right-hand side, we can get the results. And so the results for the predicted sale price for this particular observation is not great. So the estimate was 137, and the actual is 60K. So that's quite a large difference. We can get different values and see that it does a more or less pretty good job depending on the actual input. So that's a textual description. It's very detailed, but let's look at a little bit more summarized view. So we can see here that the estimate was 131. The actual was 144K, which is a difference of about 9%, which is not too bad. And this is the error distribution. So this line here is the predicted value, but in many cases, the error distribution around that is very important. So that shows, if it's sort of tall and narrow, that basically means that it's a very good prediction. If it's sort of short and wide, then it's typically not a great solution or a great prediction, and it may be lopsided or what have you. So this distribution tells a very key story. And in terms of the constituents of that solution, so how do we come up with that combined solution? So basically, these when we look at a hypo, this hypo is size 5, and so the 5 things that go into it are listed off here. So this is the average. This one is based on the greater living area. This is the neighborhood, zoning, and then the house style. So a lot of interesting input there. So for this particular result, we see that we have the average value. We see that the greater living area is in general greater than the rest of the properties. And once you've taken the greater living area into account, then after that the neighborhood plays an important role. So this neighborhood is not as good as average after having to take into account the square footage. The zoning doesn't play a huge role, but you can see it subtracts about 10K depending on, that means that depending on which zoning, it has an impact on the sale price, obviously. And then the house style, again, this house style for this area, for the square footage, and for the zoning is not as good as the average in that data set. So in terms of the other panel, so we can click on this panel. This textually describes not a single response, but the hypo in aggregate. And so basically, it says, okay, this is a gradient boosting type algorithm with the target sale price, has 5 constituent hypotheses, and the input is of size 4, and here are the input fields. And then it goes on to describe each of the different hypos that make up that ensemble and the details for each of those hypos. So this is very interesting in terms of if you want to, for example, in some cases there's certain linear relationships or polynomial relationships that will actually describe the polynomial. And so that's very, very useful for if you want to know, for example, how does age or weight or something of that nature factor into a certain decision. This panel shows a more graphical view, so it breaks it out by each field. And so for each field, this is a categorical field. It breaks out a visual representation of the hypothesis. So those are the actual values. This is the hypothesis values. This is the difference, and so this would show. So this kind of shows that this hypothesis is the guess for this hypothesis. So this is a little bit higher than average, and here are the averages. And so it gives people an insight into versus the actuals. What are the guesses versus the actuals? Here's the zoning. So zoning again is a categorical. Greater living area is a continuous relationship. So we can see here that. Yes, the greater living area, it seems to be a very linear type relationship. Again, these sort of jogs are given that there have been some other sort of categorical variables taken into account, like housing style and zoning and neighborhood. And that's why we see this kind of jogging in the result. But we can see in general there's a kind of linear relationship, and we can see here that it does really reduce the error. And again, we look at that neighborhood, and this tells us, again, that the neighborhoods do highly impact the sales price. Okay, and I think that's all I wanted to show. So again, this has been an overview of the HypoInspector. So it is a tool that allows us to look at the previously saved hypotheses. And again, thank you for watching.